To solve the differential equations using the Laplace transform, we call the first part, you're going to apply the Laplace transform. The second part, you're going to do the inverse Laplace transform. So kind of forward and then do backwards. And for the Laplace transform, we call in 7.1 and 7.2, the Laplace of the lowercase y, we use the notation capital Y. Okay. And then the Laplace of the first derivative is s. Recall the Laplace transform will turn out to be the function of the s variable. So the Laplace of the first derivative is s multiplied by the capital Y, which is the Laplace of the solution y, minus the s to the power 0, which is 1, multiplied by the initial condition at the 0 order. For the second derivative, Laplace transform is s to the second multiplied by the capital Y, subtracted by s to the first power times the 0 order of the initial condition, subtracted by s to the 0 multiplied by y prime at 0, or the next order of the initial condition. This is what we're going to use for the first round. And also, we're going to have to apply the Laplace transform of t squared e to the 3t. And this one, you have the exponential involving with the function. And basically, we can see this as the, this is the e to the power at, and this is the function ft. It's the same. Use the first translation theorem. It becomes the Laplace of the t squared, where s translate to s minus a, which is s minus 3. Okay. I would call this as a prep work, okay, as a prep work. So we already got this, we know what we're gonna substitute for the y prime, y double prime, for the Laplace transform of those, and for the Laplace transform of t squared e to the t3, 3t. So gonna be Laplace of t squared using the theorem that I listed on the right hand side here, the t to the power n is 2 for this case. So n is 2. So the Laplace of t to the second gonna be 2 factorial divided by s to the power 2 plus 1, which is 3. Okay, so it'll be 3. But you're gonna translate s to s minus 3. So that means, I'm gonna put the parentheses here. So the Laplace of t squared e to the 3t becomes 2 divided by quantity s minus 3 to the power 3. Okay, so we got all the prep work. Now we're gonna put them all in the main part of the process. So first part, we're gonna apply the Laplace transform to all terms. So the Laplace of y double prime minus 6 as the constant multiple, the Laplace of y prime plus 9 times the Laplace of the y equals the Laplace of t squared e to the 3t. Okay. For the first one, the Laplace of y double prime, which is s squared multiplied by the capital Y, which is the Laplace of the y, minus s times y at 0. Y at 0 is 2, so multiply by 2, minus 1 times the second, the next order of the initial condition, which is y prime at 0, or the 17, so minus 17. So this group is from the transform of the second derivative. And then minus 6 multiplied by s times the capital Y, minus s to the 0, which is 1, times the y at 0, which is 2. And then plus 9 times the capital Y, which is the Laplace of original, the lowercase y, equals the Laplace of t squared times e to the 3t. Now what we set aside, which is the 2 divided by s minus 3 quantity raised to the power 3. Do not expand, leave it the way it is. So then from after this point, we're going to clean up, collect the capital Y term, as we see this as s squared times y, s times y, and 9 times y. The second term has multiplied by 6. So we're going to have s squared minus 6 times s plus 9 as a coefficient of the common y. And then the rest of the term, we have negative 2s and minus 17, negative 6 minus 2, so that's positive 12, equals 2 divided by the quantity s minus 3 to the power 3. So minus 2s minus 17 plus 12, so this becomes 2s plus 5 on the right hand side, plus the 2 over s minus 3 quantity power 3. And the left hand side, just leave the coefficient and multiply by y. And basically we are going to solve for y, the capital Y. Okay, so to solve for y, leave the capital Y by itself, divide all by s squared minus 6x plus 9. So in this case, we can see s squared minus 6x plus 9 is the perfect square of s minus 3 quantity power 2. So divide all by s minus 3 to the power second. So to me 2s plus 5. I'm going to make it a separate term. So 2s divided by s minus 3 quantity second. Well, let's combine this. Let's see what else we can do as we manage the algebra. And divided by 2. So, but the last one now becomes s minus 3 quantity power 5. Okay. We are done halfway of the process. We got the capital Y. The idea of this is we're going to get back to the solution, which is the lowercase y, or the solution of the differential equation, as the capital Y is the Laplace of the lowercase y. Now we're going to, next part, we're going to solve for y by applying the inverse Laplace to both sides of the equation. Therefore, we have the y as the inverse Laplace of the 2s plus 5 divided by the quantity s minus 3 to the power second. That's first one. And then plus as a coefficient, I'm going to take the coefficient out as 2. The inverse Laplace of 1 divided by s minus 3 to the power 5. Okay. And then from the problem, as we see the s minus 3 quantity to the power second or power 5, that tells you is the translation from s to s minus 3. So s to s minus 3. With this hint or this observation, we're going to adjust the numerator of the first inverse Laplace to fit the form that we can find. We can use a theorem and then apply the first translation theorem. So to make s minus 3 appear on the numerator, we can see the 2s here as 2, same technique that what I did earlier. So 2 times, so make s to be s minus 3, take out another 3, no, add 3, sorry. So s minus 3 plus 3 and then plus 5. Actually, this is the same as the earlier example, if you recall. And this one becomes the inverse Laplace of the 2 of the s minus 3 divided by s minus 3 squared, or becomes 2 divided by s minus 3. That's one of them. And the second one becomes 11 over the quantity s minus 3 squared. Okay. And the last one, the 2 times the inverse Laplace of 1 over the quantity s minus 3 to the 5th. Now, as we see separate terms, The first one, this is the coefficient 2 multiplied by 1 over s minus 3. Okay, let me see if I can add more room into the notes here. Just 1 second. So I rewrite it as 2 the inverse Laplace of 1 over s minus 3, and then plus 11 the inverse Laplace of 1 over s minus 3 squared, plus 2 the inverse Laplace of 1 over s minus 3 to the 5th. Okay, so we can see the three individual ones. So the first one would give us the e to the power 3t. This one, you don't have to think about the translation. Is the direct formula or the direct use of the theorem as 1 over s minus a is e to the power at. So the first one came out nicely without thinking too much. But the second one is the translation as the Laplace of 1 over s squared as s translate to s minus 3. And the last one is similar way. So 2 the inverse Laplace of 1 over s to the 5th, where s translate to s minus 3. Now, since the first one is done, the second one would give us as n equals, this is s to the n plus 1, so the n equals 1. So you need the n factorial on the top, since 1 factorial and 1 is the same as the example that we did last time. So the second inverse transformation will give us the 11 multiplied by the value t. Okay, and the translation part here will make it multiply by e to the power 3t. That's the second term, and add the first term. The last term is the n is, so n is 4 because 5 is 4 plus 1. If n is 4, you're going to multiply top and bottom by 4 factorial to adjust it to be the form that we can use a theorem. So if I add another step over here, it would be like 2 multiplied by, and then 2 divided by 4 factorial. The inside is the inverse of the 4 factorial over s to the 4 plus 1, which is 5, and then translate as s to the s minus 3. And the last one would give us 2 over 4 factorial. 4 factorial is 24. It becomes 1 over 12. Okay, 1 over 12 as a coefficient. And this part of the inverse Laplace will give you t to the power n, which is 4. And the translation is multiplied by e to the power 3t. So put them all together. We have the answer of this differential equation, or the solution y, as 2 times e to the 3t plus 11 times t times e to the 3t plus 1 over 12 times t to the 4th times e to the 3t.